All right, thank you very much, Raphael. So next speaker, Jeff from Occipital.
Testing. Am I on? Okay. Hang out for the slides. My name is Jeff Powers. I'm co-founder of a company named Occipital. We produce a device called the structure sensor. I'll show you some pictures of it in a second. How many of you guys have heard of structure sensor before? Okay, decent. Better than a typical crowd. 2 of them here. Okay, good. This is good. So what I want to talk about today is some of the advances that we're trying to make in the usability of RGBD capture. So you just saw an awesome demo of RGBD capture live a second ago. We can do that kind of thing, but one thing that we're working on is how to make it easier, because there are some issues with users needing training. So let me do that. But before I do that, I'm going to show you a little bit about our company and our vision for the future. So we're excited about what we call spatial computing. There's many terms for this, but we see it as the combination of things like reality capture, which we're talking about a lot here at this conference, as well as things like mixed and augmented reality, which is more like how we're going to consume the ability to do reality capture, and then maybe things like scene understanding and semantic understanding of the world, ultimately powering future computing interfaces. It's really where we're going, I think, ultimately is a new interface for computing. But that's a little ways down the road, so where are we today? So we're focusing on reality capture. I mentioned we want to make it easier. Well, why do we want to make it easier? Why does that matter? With the same hardware, I mean, a lot of us these days are actually using hardware that's similar to the original Microsoft Kinect, but we're trying to innovate now more on software. We are innovating on hardware at the same time, but the software has to be innovated on. If you guys are familiar with Axis webcams, I used to use one of those maybe 10 plus years ago. That was kind of the cool way that you could do IP cameras. You could set up a surveillance camera, you could do a baby monitor with an Axis webcam. Axis webcams were all the rage. But now you may have heard of Dropcam. Dropcam is fundamentally the same thing. It has almost the same features. But how are these guys doing today? Well, on Amazon, you can buy an Axis web camera, almost the same specs as the Dropcam, and it's the 1700th most popular product. Not too bad for, maybe. But how's the Dropcam doing? It's doing 4, rank 4. Why is it doing so much better? And why is this essentially the top-selling camera on Amazon? And the reason is not because of its hardware, but it's because of its software and attention to detail. With Dropcam, you buy it, you go to an IP address, and you have a camera. You have a camera on the internet, I should say, rather. And they also targeted Dropcam towards baby monitoring, among other things. So with a simple user interface, the same fundamental hardware, adoption went through the roof, and sales went through the roof, and now the mass market is using IP cameras, which you couldn't have imagined the mass market using 10 years ago. So is the mass market using reality capture? No. Why? Well, partly because of usability. At least that's my part of what I believe. So one of the things that we did to try to get there to a larger audience is to make the hardware first as simple as possible. So we took the power of the Microsoft Kinect, and then we worked with the designers of Fitbit and Lytro, 2 popular consumer devices, and we threw away as much of the complexity as we could in the Kinect, and we built the structure sensor, which is a device that you can attach to an existing tablet today. You can attach it to an iPad. You can attach it to an Android tablet. And really, it's relatively inexpensive. It's $379. And if you're interested in doing RGBD scanning, capture, tracking, or augmented reality, it's probably the easiest way you can get started building things in that area today. Here's a super quick clip just so you can see someone using structure sensor. So you can scan things. You can write your own apps with our SDK. So really what I wanted to talk about, though, is how are we making this better? Where are we going from here to get it into the hands of more people, less trained people? So to motivate this, one thing that happens is we give someone a structure sensor and we say, hey, new technology, check it out, try to scan something. And what do? They look around and they find the most symmetrical, nondescript object in the entire room, and they try to scan it. And that fails inevitably because depth-based scanning technology can't really typically deal with something that is nondescript and symmetrical. So we set out to fix that with some of our latest SDK updates. So here's a symmetric object. And let's see what happens if you use our traditional techniques that we were using until recently. By the way, this is cool because we're doing this on a mobile device. I mean, this was the kind of thing that was introduced in Connect Fusion running on the top-end GPUs a few years ago. Okay, now it's running on a device, but tracking was terrible because that object is too symmetrical. So since depth alone isn't informative, we start using color information. And if we do that same thing, this time with color, it's rock solid. And we don't have any issues tracking. So really increasing the usability. You don't have to explain anything to the user. It just works, right? So what happens if you use the old versus the new? Why does it actually matter in terms of the output? Well, here's a result that we might have got with our old technology. And with our new method, much better results. This is with a consumer device, right? This is an iPad and a structure sensor. Another thing that happens is people will start scanning something and then they'll try to walk around and they'll get distracted and they'll pan out of view and the subject of scan is actually lost. And so we solve this by tracking the entire scene as opposed to just what's in view. So you can see our old method on the left fails. We can't continue scanning the sky anymore, but with the new method, we can keep scanning. Another thing that happens with consumer depth sensors like the Kinect is that if you get too close, the depth sensing fails. This is for a variety of technical reasons, but users don't understand that. I mean, they're used to cameras getting better, so they try to get as close as things as they possibly can to get more detail. That turns out to cause these systems to fail, and users don't understand why. So with our new technique, we build a model of the subject, and then we track that model. And if you get too close, we can actually just tell you that you're too close, as opposed to miserably failing like we used to do. So on the left, that's our old system. It's dead at this point. On the right, the new system is just telling the user, hey, you're too close, please step back. But it's still tracking the whole way through. So greatly increased usability for RGBD. One final example is a situation where you're trying to capture an object that looks really simple. Users think, oh, that's the most simple piece of furniture I've ever seen. Surely this should work. And it actually fails because this object is reflective, it's nondescript, and it actually doesn't have any constraining geometry if you move in a certain way. But again, we actually work just fine here by tracking the surrounding area. And so we can capture this object just fine. So it's really all about reducing the amount of training that a user needs to go through and giving them helpful tips when things are failing. We think that's one of the next frontiers in mobile capture. So how can you use this? And one of the things about Occipital, which differentiates us from some other companies, is that we're not actually trying to go after industry verticals ourselves at this point. What we're really trying to do is build a toolkit, an SDK, if you will, and a beautiful hardware device that you can adopt into your market. And you can use our SDK and you can build on top of it. And you can go after your particular market because you know about it a lot better than we do. And we just want to make the core tech that does vision and tracking and reconstruction better. So yeah, Structure SDK is free, actually. So what's in the SDK? We have things like the ability to capture rooms and do measurements. We have the ability to track positionally and hold. I'm going to show you something cool in a second using that. And then 3D scanning, which I just showed you some of our latest work in that direction. And some people are actually using it today. So it's not just us pontificating. There are some people. 3D Systems is actually using the structure sensor for their customers and deploying 3D scanning apps to the 3D printing industry. We have some medical applications, things from simulation of plastic surgery to wound measurement and wound care to orthotics and custom products. So there's a lot of interesting uses today, and we want to see that grow a lot. So what happens after you've captured reality? Well, sometimes you want to interact with it. And so one of the things that we are getting excited about recently that we've been working on is positional tracking. So we have a depth sensor, and we have this great color tracking technology. And so we can put the two together, and we can actually see how you're moving through the environment. Not necessarily to capture it, but we can build an ephemeral model of what's around you, and we can actually use that to track your position and your rotation, your orientation in space. We know how close you are to the ground. We know essentially where you are from your start point. And with that, we can do cool things like enable gaming. So here's a game that we are actually putting out as a sample. We're not a game development company, so sorry for the bad graphics. But you can see that positional tracking, the same fundamental tech that we use for scanning, can be used to let someone interact. So we have rotation, but we also have translation, which is really the new thing. So if you have a structure sensor, this is coming out, and this is kind of a playthrough, so you know what to do when you download this game. So everyone here is not necessarily interested in games. So there's other things you can do with positional tracking too. Let's say that you have a model of a kitchen that you would like to explore before you actually spend $250,000 building that amazing new kitchen. You could load your model onto a tablet, and you could positionally track yourself and take steps in the real world and imagine how those steps in the real world would correlate to steps in the virtual world. So this is me walking around my living room, but actually exploring this virtual kitchen model. Not my kitchen. We don't have that much money. But we're calling this unbounded positional tracking, and it's going to be in the Structure SDK. So anybody developing with Structure can use this as well. So to kind of sum up again, I think today we have a relatively small number of companies working in reality capture, many of them here. But we have this much, much bigger opportunity, I think, to bring reality capture and spatial computing to the entire world. And if we can bust down the barriers of complexity, we can actually get much larger adoption. And maybe people even like my mom, no, let's be realistic. She's never going to use this technology. But yeah, so that's about it. Thanks. And I hope to answer questions later, but not right now. Thank you.